All right, everyone, welcome to the screencast covering the material out of chapters 3 and 4 out of the Shepsley book. And we saw at the end of the last screencast that we got a majority that preferred Y to anything else, right? Y beat everything else. Y could not be defeated with pairwise majority rule, but it was a little weird because we had two different majorities. Well, hold on, things are just going to get a little weirder here, all right? So here's another case of Bill, Bertha, and Bob, but I've given them slightly different preference orderings. Bill's are the same, Bertha's are the same, but Bob's are a little different, all right? And we're going to do the same sort of things that we did before. We're going to use different voting rules to look at what goes on here. So let's do the majority rule, pairwise majority rule. So let's do X versus Y. Well, Bill prefers X to Y. Bertha prefers Y to X. Bob prefers X to Y. So X beats Y in that pairwise competition. What about Y versus Z? Well, Bill prefers Y to Z. Bertha prefers Y to Z. But Bob prefers Z to Y. Y gets 2 votes. Z gets 1. Y beats Z. All right. Now let's run the last combination we haven't run yet. Z versus X. So here, Bill prefers X to Z. Bertha prefers Z to X. And Bob prefers Z to X. So Z beats X. All right. So there's no socially best alternative. Every alternative can be beaten by another alternative. All right. X will beat Y, but Z will beat X. And although Z beats X, although Z beats X, Y beats Z. All right. So everything can be beaten by something else. So there is no alternative that cannot be beaten in pairwise majority rule here with these sets of preferences. All right. So majority voting does not always aggregate transitive individual preferences into a transitive social preference. So Bill, Bertha, and Bob all had transitive preferences over the alternatives, but when we aggregated their preferences, their group preference ordering actually was not transitive. All right. So sometimes that will happen with pairwise majority rule, and sometimes it won't. It depends on their preferences. If they all had the same preferences, notice, if they all had Bill's preferences, then pairwise majority rule would give us X, right? So the degree to which this kind of vote cycling, which is what we call this, we call it a vote cycle, the degree to which that's a problem often depends upon how much the people disagree with one another. The more they disagree, the more their preferences are different, the more likely it is that you will get a vote cycle. So each choice is beaten by one of the other choices, and that is a vote cycle. So their group preference relation, if we wrote their group preferences out, it would look like this. So actually we should put little g's on each of these strictly preferred twos because it's for the whole group G, not one individual person. But as we saw, Y is preferred to X, X is preferred to Z, Z is preferred to Y, Y is preferred to X, X is preferred to Z, and so forth. It goes like that in a cycle, all right? This voting rule can produce intransitive social choice. So pairwise majority rule can give you a group choice that's actually not transitive. The voters' preferences are transitive, the individuals' preferences are transitive, but the group choice is not transitive. All right, and it's not only going to be a problem for pairwise majority rule. In general, we call this finding, this outcome, a Condorcet vote cycle. And what a Condorcet vote cycle is when individuals who all have transitive preferences can produce a collective choice that is intransitive. All right, that's a Condorcet vote cycle. All right, and it happens with pairwise majority rule, or it can happen. Like I said, it just depends upon how different people's preferences are. But one thing's for sure, if there's at least 3 people and 3 alternatives, at least 3 alternatives, we can't be sure there won't be a Condorcet vote cycle. All right? It's named after Marie-Jean Antoine Nicolet de Condorcet. He was a philosopher, a mathematician, and he's the only social choice theorist that I know of who has a statue of him in the French Revolution. He actually was guillotined during the Revolution. He started out as one of the revolutionaries, and it kind of fed on itself, and he ended up being killed during the revolution. Actually, he wasn't guillotined. He died under suspicious conditions in jail. suspicious conditions during the French Revolution. So Condorcet vote cycles are an example of cyclical preferences. So we have a group of people that are at least 3 people, G, 1, 2, and 3. G is the group, 3 people. They must choose by majority rule from among at least 3 alternatives. Choose by pairwise majority rule, pairwise, meaning you're looking at only 2 things at a time and taking a majority rule vote, all right? We cannot be sure there will not be a vote cycle, all right? That is the Condorcet paradox, all right? So what does this tell us? Well, it tells us something important. Institutions are going to end up mattering, all right? Institutions are actually the rules of the game. So what's going to determine which choice is the group choice if every choice can always be beaten? Well, we're going to come up with some other rule, all right? Maybe we let somebody become an agenda setter. They decide what order we take the votes in. Maybe we set a time limit, all right? Maybe we come up with some other rule for deciding when do we stop this vote cycle, right? Because if our preferences exhibit a vote cycle when we vote by pairwise majority rule, we have to figure out a way to stop the game so that we know what our group choice is. And we call the rules of the game institutions in economics, all right? The rules of the game, and they will matter. Here, if there's a vote cycle, the voting rules and who gets to be the agenda setter are the institutions, and they could fully determine what the outcome is, all right? Whoever gets to decide the order of the votes could actually decide which outcome wins, and we'll look at that in another screencast in a minute. Given the same people with the same preferences, a different set of rules will produce a different choice. So using pairwise majority rule might give a different choice from using unanimity rule, might give a different choice from some of the other voting rules we're going to look at later. Same people, same preferences. We use a different set of institutions, and we could get a different outcome. The institutions themselves can drive the outcome. When does that happen most often? When there's a lot of disagreement. If everyone agrees, all sorts of different rules and institutions will give the same outcome. It's when there's disagreement that we see that institutions matter most.